Phases of compiler. Structure of compiler consists of two parts: analysis part and synthesis part. Analysis part analysis part breaks the source program into uh, constitute pieces and imposes a grammatical structure of them, which features uses this structure to create an intermediate representation of the source program. It is also termed as front end of compiler. Information about the source program is collected and stored in a data structure called symbol table. So, source program uh, receives the analysis phase and generates the intermediate representation. Synthesis part is the second part of the compiler. Synthesis part takes the intermediate representation as input and transforms it to the target program. It is also termed as backend of compiler. Synthesis phase receives the input as intermediate representation and generates the output as target program. And the design of compiler can be decomposed into several phases, so each of which converts one form of source program into another form of source program, target program. So phases of compiler, different phases of compiler as follows. So one, lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and code generation. So all the uh, four mentioned phases involves the following tasks: symbol table management, error handling. So this is the uh, diagram of phases of compiler. So in this diagram appears a source program or source language receives the first phase, lexical analysis phase, syntax analysis phase, semantic analysis phase, then intermediate code to the optimization and code generation finally generates the target program. So all these phases connected to the two elements, the one name called as symbol table and another one is the uh, error handler. And all these six phases, so first four phases are called as front end phases and uh, last two phases, optimization and code generation phases are called as back end phases. So lexical analysis phase. So lexical analysis is a first phase of compiler, so which is also termed as scanning. In this phase, source program is scanned to read the stream of characters, and those characters are grouped grouped to form a sequence. This sequence is called as lexemes, and which produces a token as output. So token is a sequence of characters so that represent lexical unit, so which matches with a pattern such as keywords, operators, identifiers, etc. Lexeme. So lexeme is an instant of a token. So that is group of characters forming a token. Pattern. So pattern is uh, a pattern describes the rule that the lexemes of tokens takes, and it is the structure so that must be matched by strings. So once a token is generated, the corresponding entry is made the symbol table. So the symbol table uh, construction consists the input of characters and output as token, and token template like token name and attribute, these two elements to be appear. And example here given, C equal to A plus B star C. So C as one token, equal to as one token, A as one token, plus as token, B as one token, star as token, 5 as another token. So in this uh, C, A, B, these three called as uh, the type of tokens like variables, equal to, plus, and star. These three are called as operator type of tokens. 5 is called as constant type of token. So these are all as tokens uh, generated in the lexical analysis phase. So lexemes and tokens here differentiated. So C identifier equal to as assignment symbol, A as an identifier or variable, plus as a symbol, B as identifier, star multiplication symbol, 5 is a number or constant. So here a generalized form of this particular statement, identifier 1 equal to identifier 2 plus identifier 3 star identifier number 5, constant number 5. Next phase name called as syntax analysis. So the syntax analysis is the second phase of compiler, so which is also called as parsing. So parser converts the tokens produced by lexical analyzer into a tree-like representation called parse tree. A parse tree describes the syntactic structure of the input. Syntax tree is a compressed representation of parse tree in which the operators appears as interior nodes and the operands of the operator are the children of node for that particular operator. Here shown as syntax tree representation. So equal to is considered as operator, and the child is as C is the operand. Plus is the operator. B is called as operand. Star is the operator. B and 5 is called as operands. Semantic analysis, this is the next phase. So this phase is the third phase of compiler. It checks for semantic or meaning of consistency, and type of information is generated and stored in symbol table or in syntax tree. Performs this particular phase performs the type checking. So this phase also generates the syntax tree, but this syntax tree name called as abstract syntax tree, so which consists the meaningful representation of each and every node of syntax tree. A next phase name called as intermediate code generation. So intermediate code generation produces the intermediate representations for the source program, so which are of the following terms like postfix notation, three address code, syntax tree, and most commonly used form is the three address code. So the here given one example in this particular discussion. So three address code representation for the given expression like t1 equal to in, int into to float. So this 5 is an integer number, but it is to be converted into floating point number uh, by this particular statement. And T2 equal to identifier 3 into T1. Uh, this is the multiplication operation. So then after performs the T3 identifier 2 plus T2 addition operation it is to be performed. And then after whatever results you may get, that results to be stored in an identifier. So this is C equal to A plus B into 5 and B. So this syntax, this statement is converted into all these three address code. Uh, this three address code to be like this. And here properties of intermediate code. So it should be easy to produce and it should be easy to translate into target program. Then next phase name called as code optimization. Code optimization phase gets the intermediate code as input and produces the optimized intermediate code as output. It results in faster running machine code and it can be done by reducing the number of lines of the code for a program. And this phase reduces the redundant code and attempts to improve the intermediate code so that faster running machine code will be as a resultant from this particular code optimization phase. During the code optimization, the result of the program is not affected. And to improve the code generation, the optimization involves so all the variety of optimizations like dead code and removal of dead code, unreached code name called as dead codes, and that uh, dead codes to be removed, and calculating calculation of constants in expressions and terms as another optimization, and collapsing of repeated expressions into temporary strings as another variety of optimization. Loop unrolling as another optimization. And moving code outside the loop uh, is considered as another optimization. Removal of unweighted temporary variables. Uh, it is also considered as the other variety of optimization. So here given one example, T1 equal to identifier 3 into 5.0. Instead of calling into to float, so it's simply 5 is a constant. So it is to be written like 5.0. So it is considered as one variety of optimization. And ID1 equal to ID2. Identifier 1 equal to identifier 2 plus T1. So previously, three address code, intermediate code is reduced from four statements to the two statements. So by applying optimization. Last phase name called as code generation. And this code generation is the final phase of compiler, and it gets input from the code optimization phase and produces the target code or object code as a result. Intermediate instructions are translated into sequence of machine instructions that perform the same task. The code generation involves allocation of registers and memory, and generation of correct references, generation of correct data types, generation of missing code. So in this code generation appears the registers and memory. So here the few instructions, code generation, uh, machine code instructions represented like LDF as one, and MULF is LDF refers load uh, load operation. MUL refers to multiplication of floating point number operation. LDF refers again, it is called as load operation. Uh, AddF refers uh, add floating point numbers, and STF refers store floating point number from uh, register to identify to register. So these are all as code generation. So this is the example of uh, different phases. So how your instruction to be translated from source program to the target program. In this example shown here, C equal to A plus B star 5 semicolon. So this instruction, how it is to be transformed, uh, all uh, phases of compiler uh, by seeing the lexical analysis phase. So identifiers or tokens are identified. So like A, C, A, B considered as identifiers, equal to plus star considered as operators as tokens, and 5 considered as constant token. And this receives the syntax analysis phase as input and generates the syntax tree. So this is syntax tree. Nodes are represented like this, and leaf nodes are uh, always operands. So interior node, it should be operator. So this you have to understand as syntax analyzer, analysis phase, and generates the syntax tree. Next, this is syntax tree given as input to the next phase, semantic analyzer. And semantic analyzer generates the syntax tree as output, and semantic, meaningful syntax tree to be constructed. And it is called as abstract syntax tree. And this input, this is considered as input to the next phase. So the next phase name called as intermediate code generator. And the intermediate code appears like this. So T1, so four statements, uh, three address statements uh, considered as a common intermediate code generator. And these three address codes consist the four statements and temporary variables. Here it is to be appear. So this intermediate code generated by the software, compiler software itself with the support of temporary variables, and uh, that generated to the next phase. Next phase considered as a code optimizer, reduced four statements into two statements. So then that two statements given to the code generator phase, and this code generator phase generates the output in code machine code. it is considered as assembly language code, and LDF refers to load, MUL refers multiplication operation, and ADF refers the addition of floating point numbers. STF refers to the uh, store operation. So this is the example, and another example here given, and this is considered as another example. Position equal to initial into rate, initial plus rate into 60 as an expression, and this statement, how it is to be transformed into all these phases of compiler. So this you have to understand by seeing this example.